So now what if we have double bonds? For double bonds, we use Z and E notation. We don't usually use cis and trans because that usually assumes that both of the attached groups are the same. In this case, we can have different groups attached. So if the high priority group is on the same side, we call that Z. If they're on different sides, we call that E. And so we add Z and E to the name just like we add R and S. So here are a couple of examples. So starting on this carbon, looking at the priority, bromine is higher than methyl. And then on this carbon, ethyl is higher priority than methyl. And so this guy is Z. So now we just have to number the chain with the double bonds. That's 1, 2, 3, 4, 5. And so we have 2Z, 2 bromo, 3 methyl, pent, 2 ene. Now for the second one, looking at this carbon, chlorine is higher. Looking at this carbon, oxygen is higher. So this one is an E double bond. So now naming him, we have 2E, 2 chloro, 3 ethoxy, because there's 2 carbons on this group, pent, 2 ene. Let's look at some more examples. So these examples actually combine double bonds with chiral centers. In this molecule, the longest chain or ring is the cyclohexene. And so this bond, looking on both ends, this one has a hydrogen here, so his high priority group is there. Here, it's a chain of carbons. Down, up, you have a chlorine along that chain, so this group takes priority. And so this is a E double bond. And then this chiral center has an undrawn hydrogen. Chlorine is 1. The longer chain is 2. Methyl is 3. Hydrogen is 4. He's pointed away. Thumb away, clockwise, that's R. And so now we just name it as we normally would. And so to name it, we look at the ring, because that's longer. And then the rest is a substituent. So the name of the substituent is 2R, 2 chloro, propyl. That is coming off of carbon 1 in the hexene ring. So here's a special case where you don't have to add an E. When a double bond is in a ring, you actually assume that the carbons that are part of the ring are always going to be on the same side. So therefore, anything you attach to it is always going to be coming off the other side. In this case, that's E, but it's clear that the substituent will be opposite the ring. So now for the second example. So this example gets pretty complicated. So we're going to take it one at a time. We're going to start with the double bond. So here, chlorine takes precedent. Here, the 2 substituents both have carbon. This carbon has bromine and 2 hydrogens. This carbon has 3 carbons, because triple bond, you count carbon 3 times. So bromine takes precedent over 3 carbons, meaning the top is higher priority, meaning that that guy is E. Now continuing, a triple bond does not have stereoisomers because there's no different ways to arrange around it. So you don't say Z or E for the triple bond. We only have to focus now on this chiral center. So to draw the undrawn hydrogen, It's actually here in the plane of the board. The reason I know that is because the other two substituents are drawn off the plane of the board. And so this is going to make it a little complicated when we have to put our thumb in a certain direction because our thumb is now in the plane of the board. And so now, prioritizing the groups, again, nitrogen is first. This carbon will be 2 because it's got a triple bond. The methyl is 3. The hydrogen is 4. Now, orienting the thumb when it's in the plane of the board is going to be a difficult task. You put it in the plane of the board, and then sweeping 1, 2, 3. Now you're basically sweeping from out of the board toward into the board. So if your thumb is in the plane of the board and it's facing left because the hydrogen is moving toward the left, then finger sweeping from out to in go on your right hand. So that carbon is right. Now naming the whole molecule, we have to find the longest carbon chain that includes all the double and triple bonds. And so that is going to go 1, 2, 3, 4, 5, 6, 7. That's the longest chain. To name it, we can do the stereochemistry first. So we have 2E, 6R, followed by the normal name. This substituent is essentially a bromomethyl. And so we have 3 bromomethyl. You don't necessarily have to put that one in parentheses because 1 bromomethyl is not necessary since bromine is always on the first carbon of the methyl. So that's fine. Then we have 2 chloro, followed by 6 nitro. And then the root is hept for the 7 carbons. Now the double bond is on carbon 2, N. And then the triple bond is on carbon 4, ine. And so that is the full name of that big molecule.